In this video, we're going to talk about 2.6 Objective 6, where we use the intermediate value theorem to show equations have solutions on a given interval. Let's go ahead and get started. Use the intermediate value theorem to show that the following equation has a solution on the given interval. Then use a graphing utility to find the solutions to the equation on the given interval. I'll use the Desmos graphing calculator to do that, and then illustrate your answers with an appropriate graph. Again, I'll use the Desmos graphing calculator to help me do that. So the intermediate value theorem states that if f is continuous on the interval of closed interval a to b, and L is a number strictly between f of a and f of b, then there exists at least one number c in the open interval a to b satisfying f of c equals L. So that's a whole bunch of things to fill in there, but continuous on closed interval a to b strictly between, there exists at least one on the open interval a to b such that f of c equals L. All right, for which values of x is the function 2x cubed plus x minus 1 continuous? It's continuous for all x. Evaluate the function f at the left endpoint. So we're interested in 0 to 1. So f of 0 is -1. And then at 1, we get 2 plus 1 minus 1 is going to be 2. Okay. So we're interested in trying to find a 0 in x-intercept, since 0 is strictly between -1 and 2. And the function is continuous here. There should be a 0 somewhere between 0 and 1. So it can be used because f of x equals 2x cubed plus x minus 1 is continuous on the closed interval 0 to 1, and 0 is between f of 0 and f of 1. So B. Now get your graphing calculator out so we can actually graph this here. So this is going to be 2x cubed plus x minus 1. Y equals 2x cubed plus x minus 1. And we're going to look for that x-intercept right there. And we're going to go to 3 decimal places. Let's zoom in here a little more. It'll start rounding. There we go. So it's about 5.90. That, and then if we want to be between -1 and 2 by ones, so -1 and 2 by ones, and then -10 to 10 by ones. Then it should look like that. There we go. and that matches B. It's not dipping back down like A, slowly increasing the whole time. All right, let's look at number 2. Let's use the intermediate value theorem to show that the equation has a solution in the given interval. So it's going to be at 0. Let's see, this is continuous on the interval A to B. L is the number strictly between f of A and f of B. Then there exists at least one C value in the open interval A to B such that f of C equals L. So again, continuous on A to B, strictly between. There exists at least one on open interval A to B, f of C equals L. And we're just going to look at the left-hand side of the equation here. It's continuous as long as plus 18x to the third plus 6 is greater than or equal to 0. But I'm interested specifically if it is on this 0 to 1. That'll be continuous. Let's go ahead and just look at the graph here. X to the fourth. Square root x to the fourth plus 18x cubed plus 6. Okay, so it's not continuous for all x. There's a minimum x value there. I don't think there's a maximum x value, but definitely between 0 and 1, it's continuous here. So that's what I'm interested in. Continuous on 0 to 1, but not for all x values. It's restricted. So at 0, that's going to be the square root of 6. And let's go ahead and 2.449 is great. It's an approximation, 3 decimal places. For the right endpoint, which is going to be at 1, it's f of x. F of 1 be 5. So because 4 is between 2.449 and 5, it can be, and the function is continuous on the interval from 0 to 1, then it can be used to show that there's at least one C value between 0 and 1, where the function is going to equal 4. Let's go ahead and find the point of intersection here. My answer is going to be 3 decimal places here. 0.803. Did say 4, right? Yeah. .810. That's actually it. 810. There it is. And 0 to 1. 1 by 0.2s, and then 0 to 10 by 1s. Okay, and then it's going to look like that, which is the point that we're interested in is over here. That looks like C to me. All right. Again, all these same things. It needs to be continuous on A to B, and then strictly between. There exists at least one on A to B such that f of C equals L. And that's going to be continuous because it's continuous everywhere for all x. So that's B. Now let's go ahead and stick in the left endpoint of -1. So that's going to be a -1 is 1, plus 6 plus 7 is 14. Right endpoint of 5 is -125. 6 times 25 is going to be 250. Minus 35. So this is going to be 125 minus 35 is going to be 90. Oh, this is 7 times 25, not 7 times 5. This is 7 times 25. That's almost, that's 175. That's 250 minus let me just use my calculator here. Negative x cubed plus 6x squared minus 7x, f of 5 is going to be -10. All right, 0 is between there, but we're actually interested in where is it equal to 4. So 4 is between -10 and 14, so that's good. It can be used because 4 is between f of -1 and f of 5, and the function is continuous on the interval from -1 to 5. That's A. All right, let's look at the graph here. This is between 1 and 5, 1.586. Now we want to see where it's equal to 4. F of x is equal to 4. Over here should be a, there we go. There we go. So there's actually several answers here. There, and there. So we're interested in all three of those. So that's negative 0.414, comma 2.414. And then that's exactly 4. So we'll call that 4.000 to keep everything to 3 decimal places. And let's see, -2 to 6 and 1. And we have -681. Right? And it should look like this with these 3 points up here. Like that. So that that panel doesn't squish it at all. This is what it should look like. And that's going to be A. Let's look now at number 4. Use the intermediate value theorem to verify the following equation has 3 solutions on the interval from 0 to 1. Use a graphing utility to find the approximate roots. So we can go ahead and say that the function is continuous on 0 to 1, and 0 is between f of 0 and f of 1. If we find f of 0, we get -2. If we find f of 1, we get 70 minus 73 plus 23 minus 2, be -3 plus 21 is going to be 18. So 0 is between -2 and 18. That's C. And then let's go ahead and plot this. $70x to the third minus 73x to the second plus 23x minus 2. And I'm interested in x-intercepts here. And since it's cubic, there should be 3 of them. All right. And we have 0.4, 0.5, and 0.1429. 0.1429 is the furthest to the left, and then 0.4, and then 0.5. And number 5, which is our last one for this video, use the intermediate value theorem to show that the equation has a solution on the given interval. Estimate the solution to the equation in the given interval by using a root finder. We'll use our calculator. So cosine of x between 0 and 3 pi over 2, we know that cosine is continuous everywhere. So again, we need to make sure that it's continuous on A to B, that strictly between, the value we're looking for is strictly between the f of A and f of B. Then there exists at least one C value on the open interval from A to B, such that f of C is equal to L. The function is continuous for all x, so it's going to be continuous on the interval from 0 to 3 pi over 2. That's A. Value for the function at the left endpoint, cosine of 0 is 1. Cosine of 3 pi over 2 is going to be 0. So the function is, let's see, we're looking for x equals cosine of x. So we want a place where cosine of x equals x. Let's look at cosine of x minus x equals 0, maybe. Not really sure. Let's see here how we did this. Between 0 and 3 pi over 2. So let's look at cosine x minus x. Let's do this in radians. Let's make sure we're in radian mode, and we want to be between 0 and 3 pi over 2. There is a 0 right there at 0.739. And they're going to say that the function is continuous on that interval, the value of the function at the left endpoint is negative, and the function value there is positive. So there needs to be at least 1 0 in between. And they're looking at the function x minus cosine x is what they're looking at. Equals 0. Okay. So that is -1. And then this is going to be at the right endpoint, 3 pi over 2 minus 0 is 3 pi over 2, which is about 0, or is about 4.712 if you check that with the calculator. Right? So we switched from negative to positive. 0 was in the middle, and there had to be at least 1 0 between 0 and 3 pi over 2, and it's right there at 0.739. All right, that's it for this video, and we will come back next time and talk about 2.6 objective 7. See you for the next video.